Hey guys, welcome to our channel. So we're through decoding Manwich. Um, we got everything we needed to get out of that, and now we're trying this alphanumerical thing. So the backstory is we discovered that these conversions would go on infinitely, MN, then 1314 in the alphabetic order, and then you could break 1314 down to 1 is A, 3 is C, 13 is M, 1 is A, 4 is D, and 14 is N. And then you could break that down again into numbers, and then back to letters, and then back to numbers, and you could go on to infinity. You could do the same thing if you started with numerology side, 45, DMVENW, and then convert that back to numbers and then back to letters. And this could go on infinitely, and eventually you could smash these numbers and letters together and run categories again. Also, create equations. And your fingerprint is right here, MN. And much like the fingerprint of Joan Jett and the Blackhearts I Love Rock and Roll Stand to Dancing is STC. And that could go on forever. But we're on MN now. And since this goes on infinitely, we had to pick a finite place to stop. So we stopped here, and we stopped here from each side, from starting with the alphabetic order and starting with the numerology chart. And we paired those off. We paired these letters and numbers off, 2 and 2, so that we ended up with MN13, AC14, MA45, DN41, MN32, DM25, VE14, NW23. Now we've got that to run through the stock market and finance, and now we're on genetics. And there's quite a bit there. So we start with MN1. And MN1 ends up being MN1 gene. And it provides instructions for making a protein whose function is unclear. So a protein coding gene, basically. And the protein's function is unclear. So MN1 gene provides instructions for making proteins. All right. If we move on from that, you have N13. And N13 ends up being nodulian. I don't know if I'm pronouncing that right. 13 gene. It's the N13 gene. May be involved in nodule organogenesis rather than in the processes related to nitrogen fixation or interactions with the bacteria. May regulate nodulating by controlling the levels of freely available cytokinesis. So you have the N13 gene, basically. Now, if you move on from that, you have N1, and you come up with FOXN1 gene. And it provides instructions for making a protein that binds to specific regions of DNA and regulates the activity of other genes. So the FOXN1 gene. All right, if we move on from that, you have 13A. How about TEX13A gene? Testis expressed 13A. Testis expressed protein 13A. Testis expressed sequence 13A protein. So this deals with proteins. TEX13A. Imagine that. But if we move on from that, you have 3A, and 3A ends up being spastic paraplegia type 3A. Spastic paraplegia type 3A is one of a group of genetic disorders known as hereditary spastic paraplegias. These disorders are characterized by muscle stiffness, spastically, and weakness in the lower limbs, paraplegia. Hereditary spastic paraplegias are often divided into two types, pure and complex. So, spastic paraplegia type 3A, a genetic disorder. All right, if you move on from that, you have AC1. How about gene AC1? AC1 protein. So the AC1 gene apparently makes the AC1 protein. It's a protein coding gene. Imagine that. And cotton leaf curl virus. So, if we move on from that, you have C1. How about mutation screening of the C1 inhibitor gene among Hungarian patients with hereditary angioedema? So, C1 inhibitor gene. All right. So if we move on from that, you have MA4. Muum mantiquium isolate MA4 tRNA-LEU gene, tRNL gene, partial sequence. So there's your MA4, and it deals with a gene. If we move on from that, you have A45. And A45, how about Uniprot KB P20198 A45 underscore SSV1. Gene A45. So A45 gene and protein, uncharacterized protein A45. So the A45 gene deals with proteins. A45 protein. Imagine that. More protein coding genes. All right, if we move on from that, you have A4. Right? Yes. You have EFNA4 gene. ENFA4 gene. Ephrin A4. It's protein coding. Again. So A4 is another protein coding gene. All right, if we move on from that, you have 5D. And distal arthrogryposis type 5D with a novel ECEL1 gene mutation. So this deals with a genetic disorder. Distal, this word, arthrogryposis syndrome. And type 5D is a subtype of DA type 5. So you got a genetic disorder here that they're looking at, apparently. All right, if you move on from that, you have DN4. How about gene? How about the DN4 gene? Gene class reaction to something. Diuraphysis noxia. Yeah, so it's a gene. Triticum gene. Gene DN4, though. The DN4 gene. Yeah. I can't pronounce this stuff, guys. I'm not sure what it is, but it's definitely a gene. All right. If we move on from that, you have 1M. How about MT1M, metallothioneine? 1M in Homo sapiens. Official full name, whatever this word is, 1M. It's a gene ID 4499. So 1M gene. I'm not sure what it does. I don't see that. But it's definitely a gene. Gene type protein coding. It's a protein coding gene. All right. Imagine that. I should have known. If you move on from that, you got N3. PKN3, protein kinases N3. So it's another protein coding gene. So there's you another protein coding gene. If we move on from that, you have 2DM. Genetics of diabetic neuropathy in type 2DM. Candidate gene analysis for the pathogenic role of inflammation. So this is a type of diabetes, it looks like, which is hereditary, which is genetic. So they're looking at a genetic disorder, a genetic disease here. All right. If we move on from that, you have M2. How about M2 testing? M2 testing is a carrier screening test for a genetic variant that increases the risk of placental mediated pregnancy loss and complications during pregnancy, such as preeclampsia. So this is a M2 is a genetic test. It's testing that involves pregnancy. Genomic prediction up here. Clinical laboratory. So M2 testing. All right. If we move on from that, you have DM25, I believe. That's where we're at. DM25. Oh no, I lost it. Give me a second. DM25. Oh, we're coming forward. DM25. It's right here. Sorry about that. I lost myself for a second. These do get confusing. DM25. Anti-SARS-CoV-2 spike S2 antibody, DM25. So this deals with the CONVID's 1984 antibody, DM25. Not going to say anything more about that. All right, if we move on from that, we get something that I didn't look. I must have skipped the window I opened. But if you move on from that, you got VE1. And VE1 is a gene ID here. Gene symbol VE1, gene type protein coding. So you got another protein coding gene there. And if you move on from that, you have Fort N, controlled ploidy reduction of pluripotent 4N cells, generates 2N cells during mouse embryo development. So 4N deals with 4N cells. All right. And if we move on from that, you have the last thing coming forward, W23. And W23 ends up being the origins of 168 W23 and other Bacillus subtilis legacy strains. So W23 is a Bacillus subtilis legacy strain. See if we analyzed 17 legacy strains dating to the early years of B. subtilis genetics. So, yeah, I don't think there's much more to say about it. Subtilis legacy, Bacillus subtilis legacy strain W23 and VE1 4N. Yep. And that gets you through going forwards in genetics. We'll come back next. Either later today or tomorrow, we'll come back through genetics. That'll be part 3B. This will be part 3A. We got to do this forwards for one video, backwards for one video, or we'll be sitting here for half an hour or better. So, anyway, pretty interesting stuff. A lot of protein coding genes, a few genetic disorders. But definitely a lot of hits and a lot of stuff to go through. So I apologize for the length of the video, but that's what you got. That's what's there. So we'll do genetics back next. So for now, guys, thanks for all your thumbs up, thumbs down when appropriate. Thanks for your comments, leads, feedback, and subscriptions. And thanks for watching, guys. And for now, you guys have a great rest of your day.